Okay, hello everybody. Welcome back to another incentives and perspectives video. So, pretty much what we're going to be focusing on for today is science and why the research field has some problems and some things it needs to change. And I am going to propose that we change the statistical method by altering the cutoff a little bit because of the fact that I mentioned before in some of my other videos, more about my book reviews, but where we're really bad at analyzing random chance. And we think that when we have random chance and it's a super low number, we just think that it's never going to happen, but that's not true. And so we're going to start off with understanding and looking at what is a very popular metric in research papers that kind of determine if they're useful or not. So one of the most popular metrics is this thing called a p-value. And all you need to know is that typically the gold standard is 0.05. Now, it's like a sliding scale, so it's not really like anything special about, let's say, 0.05. It's just that everyone made that as the cutoff and it's just stuck with it, and now everybody uses it. So it's just convention, okay? And what does this mean? This means that, okay, your results that you do your research, you do your like experiments, all this stuff, you get the data, the results, if you have a p-value of less than 0.05, that means, hey, look at that, right? That means that your results have a 95% chance of being correct due to some like actual factor, and they have a 5% chance that they were due to random chance, okay? So it's kind of saying 5% of, there's a possibility of 5% that these are just random results, okay? Now you may be like, well, Ryan, 95% compared to 5%, like that's pretty low. And I would agree. But the problem is when you import this and kind of, use it time and time again, repeatedly on a scale that is just astronomical. So I kind of searched it up, right? And we have up to, like, let's say from beginning of science to now, so that means many, many years, we have around 100 million research papers published, okay? And so if you look at this number, okay, and there's a lot of nuances, but let's just imagine, take 5% of these, okay? And that means you get 5 million. 5 million research papers out there are just due to chance. Due to random chance, just like things just randomly happen, and then we perceive some sort of pattern in this, and then they write a paper about it. Isn't that a lot of papers? Well, you may be like, well, Ryan, maybe that was like, before the 20th century, right? Or before the 21st century, right? Before the 2000s. Maybe that was all the 5 million. Well, not really. Like, these 5 million could be distributed all over the place. And another thing, will you be like, okay, well, Ryan, like a lot of papers don't even get cited. Okay, yeah, I agree. Some papers get like all the citing, like all the other papers use this paper, and then some papers don't get cited at all. But the problem is, like, how do you know where these are? Because you don't know. That's the thing. Like, it's a 5% chance, but it never said, oh, whenever it happens, it's going to present itself, say, hey, this is the chance paper, this is the one due to chance. No, we have no idea. So it could be the insignificant ones, right? It could be that. Or it could also be the most cited ones. And, if you think about 5 million, like, there's a good chance that maybe at least some of those are highly cited papers, right? Like, out of 5 million, you're telling me there's not just 5 papers that are highly cited out of the 5 million? And this is where you get into the, to quote kind of Nassim Taleb, right? You get into extremist stand, which is just saying that, like, this has an outsized impact. Because if only 5 papers are, you're like, oh, 5 papers due to chance, right? That are well cited. It doesn't matter. But it does matter when the citations go up to like thousands of people citing it, 10,000 of people citing it, even more. I don't really know. I'm not that familiar with all like this numerical citation stuff of how prolific it is because I'm not a researcher. I'm not established researcher myself. I do research for a lab, but it's like I'm not out there, always citing other people's papers, and they're not always citing my stuff, right? But it's like, imagine if you just had one paper that had like 10,000 citations on it or something like that, right? Well, if that one paper is due to chance, that would be a very big shift in everything. And you're telling me that you can't just have one paper out of 5 million, and these 5 million are all supposed to be due to chance, and you have one paper out of them that is highly cited. And so if you start to think about this, you're like, wait, this is actually a problem, right? This could be an issue. And then we're going to bring in, like we like to do, right? Incentives and perspective, human aspect here. Okay, so paint this picture, right? You're a researcher. Because when you do research, right, you don't necessarily know what the outcome is before you do it. That's the whole reason you do research. So because of that, you invest a lot of time and effort into something without knowing if it's going to have a meaningful result. And that's why research is difficult, because sometimes you don't get a meaningful result and you got to start back from point one, right? Or just from square one. So if you think about that, you're like, okay, let's say I put decades and decades of my time, right? And then I collect this data, we're analyzing the data, and we're starting to notice, hey, there's not really any pattern here. And I'm like, wow, ouch. Like, ouch, you know? Like, man, I spent decades of my life and I just wasted it because we didn't find any pattern. You're telling me that all I could publish, and again, most papers won't get published that have null results. So this is why we have an underappreciation for things that didn't work. Everybody's like, oh, I want to publish what works. But everything else that didn't work, oh yeah, we're not going to publish that. Because if we published it, like, it just doesn't look good. It looks like you're ineffective, right? And then all of a sudden, 10 years later, somebody tries to do the same thing you did because it wasn't published and they didn't realize that you already went down that rabbit hole before. So does it show you like how important it is to actually like publish incorrect stuff and point out like this was wrong and what went wrong? But of course, you know, like we can't do that because, you know, that would hurt our egos as researchers, as human beings, that we're not special and that we make mistakes and nobody can accept that and nobody can publicly announce their kind of mistakes to everybody and nobody can do that, right? So this is the issue we're kind of faced with, okay? And what you're going to do in that situation, right? You're thinking about, okay, you got a family, right? Your research is not paying you that much. You're trying to get to be a PI, which is a principal investigator, have your own lab, and then finally make like big bucks, or at least, you know, make enough not to be on like food stamps or something like that, right? So like, okay, what are you going to do? You're going to tell your statistician, hey, just try whatever you can. Combine that data in as many ways as you can. Just find something that's going to make it significant. Find it so it can get underneath that golden 0.05 cutoff, that p-value cutoff, right? Because as soon as you get underneath that, you know you can go publish it. It doesn't matter because you'll say, hey, look, we got a significant result. It's less than 5% due to chance. Well, I am proposing today that what we should do in the academic communities is if we actually, and again, this is a maybe contested thing, right? I don't know how many people actually care about doing research that matters, but like if we actually care about research that matters and want to effectively deploy capital in the sense of you're giving out grants to researchers to go do things that have a 5% chance of being completely due to just random toss of the dice. Well, why don't we try to improve that situation a little bit? You know, why don't we say, oh, you're giving them money, that's great. But now let's make it, you know, convention to use a 0.01 P cutoff. And this means that there's a 1% due to random chance, right? And you may be like, well, Ryan, 1% is still like pretty big, right? Because you could still use the same argument you just used. Like 1% of 100 million is a million. In a million papers, there could still be, yes, I agree. But what do we get from that? We get a 5x reduction in the number of papers just due to random chance. And I think that would help. And that's also a 5x reduction going forward too, right? We're only looking retrospectively at how many papers have been published, but you have to also consider in how much scientists are being paid, or even if they're not being paid, how much of different universities' funding they're using. And as a result, right, like how many dead ends are they going down, okay? And if we do this, right, it's definitely going to make it much more difficult. In fact, it's probably make academia more competitive because now everybody's like, shoot, right? Like I can't even publish, you know, something that says 0.01. And so now, but what it's going to do is it's going to solidify the base of things that we're very sure about, okay? Because yes, there's still 1% chance it's wrong, but I like the odds of 99 to 1 even more than 95 to 5, okay? And I think that this would benefit a lot of different fields in science who currently publish papers, do have research, and I think that this would be a net benefit, right? Because as a society, we don't want to have this like institution of science that says so effective, says all this stuff, right? And then all of a sudden, you know, it publishes these things that are like just due to random chance and everybody believes them, and then it's just like a waste of everybody's time, waste of scientists' focus, waste of their intellect, waste of their capital that we're giving them, waste of people who read it, waste of the news articles that like cover these things. And the second thing I want to do is I want to remove all observational correlational studies, okay? And you may be like, whoa, Ryan, that's a huge group there, man. Like that's a very large group. Like that may even be more than like, like 100 million papers, that might be like almost half of it or a third, right? Like, why would you want to do that? Well, because what is it doing? You just find data, you pattern match, right? And I don't have any problem with it particularly, except for the fact that there's been multiple instances where people do one, no, not just one, they do two, not just two, they do 3 observational studies. And then you do a randomized control trial, which is like the gold standard at actually proving causality. And it proves all the observational studies wrong. So what does that mean? Observational studies, like in science today, we know that they're not that useful. But then why are we allowing researchers to still do it? Like, why are we allowing them to still work on these things and still publish these things? Like, why were we contaminating the scientific literature with this stuff that could be and most likely is just wrong? Like, if we can't even have a news headline that doesn't try to imply causality some way, like, for example, oh, stocks went up because ceasefire negotiations. How do you even know those two things are correlated? You're just putting the two together, right? So if we can't even do that with something as simple as a news headline, how do you think we're going to respond when we put together all these different like dimensions and aspects of data together? We try to find all these patterns, and with people's, think about it, with people's legacies on the line, with people's livelihoods on the line for this. They are directly incentivized to try to find some sort of pattern in the data, no matter how crazy it is, to try to just draw some conclusion so they can publish. Like with all things, right? We like to imagine scientists are so pure, they're so amazing, nobody would hurt them, all this stuff. Yeah, there's some that are out there, but there's also people who are in there and who are like, yeah, I need to find a relationship, man. Otherwise, I'm getting shipped out back home because my visa's expiring because I'm not productive enough in my lab, Like they need to renew my sponsorship, right? So you can't blame these people, and I agree with that. But it's like we as an institution of science need to really do a better job. We need to remove these kind of studies because they're just tainting and wasting people's time. And they're just making it more confusing. The example I drew from is just like, there's a lot of nutrition papers out there that are all observational, and they're just completely, almost utterly useless because you can draw them one way and the other way, depending on changing some variables. So you just have this war where these statisticians are just in opposing camps, and they're already married to their beliefs, and they're just fighting the data to prove themselves right, and then have this fake argument where they're actually not really being objective about anything. So it's just like, okay, let's just get rid of that. Okay, talk to me later when you have an actual randomized control trial. And yes, I know this will reduce the number of papers. Wow, I know. Wow, that's crazy, Ryan. Wow, you're going to put some scientists out of business. I know. But it would increase the percent of papers that are actually due to real phenomenon, not just random chance. We would have a 5x increase in the number of papers, 5x reduction in the number of papers that are just due to random chance. And if we remove a lot of observational correlative studies, the percentage of our academic literature that's being published every single year that people are just trying to fight to publish all the time will be much more pure and will actually have results in them that matter. And we'll waste less resources, we'll waste less time on things that are just wild goose hunts, wild goose chases, and smoke and mirrors that people are doing, and they're pulling on us just so they can advance to the next step. Again, we can't blame the individual, but we have to take action as a whole, as a scientific community, to be like, hey, this is a problem, right? And be like, when did we ever decide 0.05 was the cutoff? If you think about it, you could have done 0.06. But of course, we like nice round numbers like 0.05, and we think that 5% chance doesn't matter. Yeah, I agree. It doesn't matter if you're, let's say, if I was to put a bet, would you rather bet $100, right, for a 95% chance of winning and 5% chance of losing? Yeah, of course, I'm going to bet that. But would you bet that every single time, again and again and again and again, where the cost of the 5% is very bad, right? Over 100 million papers, that becomes a pretty big cost, right? Because then you're thinking about the difference between 1 million and 5 million is saying 4 million papers just due to random chance getting eliminated. So yeah, in practice, when things start, yeah, it's fine. But now we're at the point we need to really look at this a second time. We really need to think about this, because this is not going the direction we want. And if we really want to advance, we can't be wasting our time and energy on all this tomfoolery, on all this kind of smoke and mirror activity where there's nothing real being found. And we're just data manipulating with newer and newer tools, newer and newer statistical tools like hard, right? Like all these other like, oh, computer science, like laptop heavy, computational heavy skills, right? We need to make sure things actually matter. So that was kind of my spiel on that. If you have any questions, put them in the comments below. Otherwise, that's why I think we should change the P cutoff to 0.01 and remove all observational coordinational studies from the scientific literature so we stop wasting energy, stop wasting intellect, and stop wasting our time.